for your introduction, and good afternoon. The topic of my presentation is the end user story that we have developed in my company, Tidal. I will be presenting the work of my colleague Blanca Araujo. And well, as you already know, I think iProd is a research collaborative project. In this project, we get together a different group of partners from different backgrounds, with different experiences. We have universities, we have research centers, and there are another set of partners which are end users. So I'm bringing here today the point of view of the end user of this project. So I will not be given technical explanations on how the software works or how the issues about the software, but the use of this software. So first things first, so let me start by stating the main aim of the project, the general aim of the project, which is to improve the efficiency and quality of the product development process for innovative products by developing a flexible and service-oriented software framework, which is aimed by reasoning and operating on a well-structured knowledge, be able to be the backbone of the computer systems that are used in the product development process. So this is the big general definition of the aim of the project. The thing is that this framework software aims to be general so that it can cover the needs of different industrial fields, like aeronautics, automotive, and home appliances, but at the same time it aims to be able to get in detail on the differences and the specific things of each of these different fields. So about the product development process, what we focus in the iProd software about the product development process is to be able to capture the requirements of the customers at the beginning of the process, so that we can transfer these requirements into technical specifications, and from that we can set up a planning of activities of testing and simulation that need to be performed during the product development process, so that we can then follow this plan. We can evolve in the design, and in the end we can do the verification and validation of the design that we have performed. However, it is sometimes we find sometimes the case that the product development process is not sufficiently structured or organized, and we can find the situation that in different fields of application, each of the companies are using different processes for that. So what we have done is that we have mapped the existing knowledge in international standards in the ISO 15288, which is an international standard defining the life cycle assessment in terms of the processes that are involved in this life cycle and the activities. So we have mapped the terminology from this standard, and we have introduced this into the iProd software framework. So, about the end user stories, the first thing that has been done by the end users is to provide data necessary for the development of this software framework. We have done it in the work package 2, and we have done this through a specific questionnaire that was developed inside the project, the consortium, and was distributed through the end users. And within this questionnaire, we were asked to provide a lot of information. We have provided information about the knowledge and the data needed to carry out the development of the products. And this is including information about the tests that you have to perform, about the planning of this test, about how is your system, your subsystem, relationship between the different parts, information you create during the testing, how you manage this information, also about the validation that you perform, a lot of information. We have also contributed in the creation of correlation matrix for each of the specific use cases. It means that the previous information that was collected is organized and structured in a way that it can be useful to be further treated by the software. And we'll come later into the more extended explanation of this correlation matrix. We also provide data about the testing management. You have seen a presentation in the previous session about the optimization of the workflow. And if you know what are the tests that you have to perform, you know the duration and the people who is involved in this test, you can in advance optimize the work that has to be performed in relation to testing. We also provide data about the knowledge-based engineering. With this, we aim to promote the use of virtual testing. We also address the use of the simulation models during the development process. We compile all the information, we organize it, we have it in a structured way, and it is available to be accessible by the users of the software. And we also use performance indicators. These performance indicators are, from one hand, taken from the experience of the end users, and it also serves to evaluate what is the evolution of the projects, the progress of the project. So about our particular use case, the sit-out user case, we are we are contributing with an example in the automotive field. This case is the development of the suspension arm, which is the part that you can see in the figure. This part is made of the main body and another subsystems, which are the lower bushing, the upper bushing, the front bushing, and the pin axle in this, with these subsystems. We define the connection of this part with other parts of a more complicated steering system. So for each of these subsystems, we will have different requirements that need to be taken into account in the product development process. So the starting point for the development process of this product is to receive from our customer the requirements and the test specifications and the standards that he expects the product is going to meet. So basically, this information is collected by the project manager, and this project manager works together with a development team. The development team is made of three main groups. The design team, this is the team which is working in definition of the geometry of the part, and is creating the initial data, which is distributed to the other parts of the team. The virtual test team or the simulation team is the part of the group who is responsible for developing the simulations, the CAE, so that you can guarantee that the part is fulfilling, is meeting the requirements, the mechanical requirements in this case, of the part. There is another team, which is the manufacturing design, related to manufacturing design, because we have to define the manufacturing process for this part. I have to explain that in this particular example, the situation was that our customer already had a supplier for this part, but he wanted to have a new supplier. And this new supplier was going to provide this part with a different manufacturing process. So incorporating the requirements, additional requirements, let's say, that are imposed by the new manufacturing process in the design was a additional point in the development of this part. This part is made by some casting. And apart from the previous people working on this development, we also have people working on the characterization of the material properties and the testing of the parts themselves. So what I want to transmit is there is a group of people working together, managing with different information, and you need to have a good cooperation among them and exchange of information. So what you see here is one of the tables that has been created in the project, in which we have collected data about the requirements that this part has to meet. These requirements are organized in different fields. Some of these requirements are related to the assembly process of this suspension arm system. Some are related to the machining process of this part. And some others related to the manufacturing process in particular. There are many more, but what we have done is to simplify this to be something that can be managed in the development of the software. So, in organizing this information in this way, you can see in the left column, in the yellow column, you can see the list of the performance that are requested to this part, to this component. Then you can see the target that you fix for this performance. You have the relation with the test method that you apply to assess this target and this requirement. And we also include another information regarding the impact of the fulfillment of this requirement in the complete system. So all these of the examples shown here are very important in the development. There are many more which has not been included in this description. So what are the advantages of collecting the information in this way? This information normally is available in our group, but we don't get all these together in this way. So I want to remark that this is something that has been done in the project thanks to the creation and definition of these tables. So the good thing in doing so is that we have a common point of information. Everybody can easily access to these tables and get a clear overview of what is being done. We are structuring the information. It's very easy to understand and follow. And we are relating the information to each of the subsystems, which is also important. And later it will be also shown that it's important for the correlation matrix. We are also establishing the performance targets for each of the tests that has to be performed. And we have also the relationship of the different subsystems to the test that has to be performed. And in the last column, as I said, we can prioritize which test and which performance are more important in the development and has to be met yes or yes. You cannot fail there. There may be others that at some point you can decide if you want to improve or not, but you can clearly see which ones are mandatory. So the next step in our way of working, we would start with the design of this new component starting from the table you have seen before. But now in the iProd project, we have also received this correlation matrix, and we have organized the information in a different way so that it can be more usable and can be used by the software framework to give, let's say, a reasoning on how the things are being done. So we have basically the same information. We have all the performance. It's impossible to be seen here, sorry for that. But here you see in this, in this column, the list of performance and the technical requirements associated to these performances. We have the targets, and we have the test methods that are being used to assess these targets. And here we are adding the list of components or subsystems, and we indicate which of these subsystems is affected by each of the targets. So this is the basic description of what the correlation matrix is. So now that we have this, we can start with the design cycle of this project. This is an iterative design cycle, and it starts with the characterization of the material properties. In this case, in which we are applying different material manufacturing methods to get this product, it is important that we can characterize the material properties because they are affected by the manufacturing method. We also take into account the specifications and loads, as has been explained before, so that we can start with the design. So we start with the initial definition of the geometry for by the design team. And this geometry is analyzed with simulation in two different fields. These are the calculations that are done by the mechanical team, let's say. We are assessing that we are meeting all the mechanical requirements with these calculations. And in parallel, we are also working in the development of the manufacturing process. So we have to combine the outcomes of these two different teams working together. And this is important because it can happen, it may happen that you can get to contradictory solutions to the problem, because you may find that at some part of the product you get a higher stress concentration, so that you want to change the geometry, you want to increase the size at some point, and in doing so you may be creating problems in the manufacturing process. So it's important during the development cycle to coordinate these two teams to get to an optimum and balanced solution in the design. Once this design can be considered finalized from the virtual testing side, because you get to a solution that is meeting the requirements in the computer, we go to prototyping. Prototyping is an important phase because it's the validation of the manufacturing process. So when you have the first physical parts, you can check if your manufacturing process is giving you an appropriate piece without defects, or if maybe you can have some problems during the filling of the part, or you may find some voids inside, or oxides, or no. Until you do the prototype, you cannot be sure that the manufacturing process is okay. So this prototype is the validation, we can say, of the manufacturing process design. And then, once this is fulfilled, we move to the next step, the testing of the part, which would be the validation of the mechanical design of the part. What we do is to complete the cycle. If any of the validation that comes from the prototype, so for testing, is not met and is not what is expected to be from simulation, the cycle continues. We fit the information we have into the models we already have. We update everything and we continue with the design loop. So it is important to say that in the iProd software framework, we are introducing all this knowledge that we are creating in the cycle into the software. So in the next steps, it would be something in the background of the software that can help you better develop the next processes in developing new parts in future. So now that I have given an overview of what we do in a particular example, I would like to explain what are the advantages that from an end user point of view we expect to get from the iProd software framework. So in order to evaluate the performance of this design process with a new tool, with iProd, we use a set of key performance indicators that has been defined to qualitative and quantitatively measure the project progress and the impacts. So we, at the end, have the experience of how we do the things conventionally before, how we do now with the new tool, with the new software, and we will be able to compare what are the benefits of using it. Which are these key performance indicators? Well, first is the reduction of the new product development time. I think it's very easy to see that every industry will want to achieve is a reduction in the development time. Second is the reduction in the product testing cost. I think there's no need to further explain, but you can imagine that the cost of a prototype can be from 10 to 50 times the cost of a serial production part. So the less parts you have to use in testing is the more money you are saving. So it's very important to reduce the number of testing. We also consider as a key performance indicator the reduction in the product development, warranty claims, and field repair costs. And last, also the reduction in the design and manufacturing deficiencies, because we can improve the development cycle using the iProd software. So I will briefly explain these key performance indicators and how we think we can get to achieve improvements in these different indicators. So when can we actually reduce the product development time? We can do it in the project setup at the very beginning phase of the project, because we can use previous experience from similar projects, thanks to the information collected in the software. We can also save time in the project review and assessment that every project has. And we think we can also save time in the project reset after verification in case there is a failure. So in this cycle I have explained, if we find that at some point we are not getting the expected result and we have to reset and we start over with this cycle, we will not be starting from scratch, and we can learn from previous experience as well. So, how do we save this time? First, we can reuse the list that we have created before and the knowledge. I think this is one of the most important added values that an end user can get from the iProd software, because every company what needs to have is to keep the knowledge that has been created within the years and experience in a place where it can be accessed by new engineers coming in the company, as Roberto said in the previous session. We also have an advantage in the sense that we have one only single source of truth. So all the information is stored and accessible and traceable for everyone. So there is no need to go through one only person, I could be the project manager, to get information about a particular aspect in the development cycle, about the test, the simulation. All the information is there, and all this information is available for all the people working in the development process. And this is a very important point also. We are able to get to a better communication, because, as I said, all the relevant people is included in the loop. So we don't have to be aware of or letting know everyone what is the development of the process, what are the achievements. Everybody is able to get connected to the tool and be up to date in the status of the project. So we can even have real-time notifications. And this will lead to a better planning and review assessment. So there is no need to do the conventional weekly or monthly progress meeting so that I can update the team on what we are doing, what are the results, but automatically and in real time we can inform the people on how the things are going. So we also, having one single source of truth, we can save time in collecting information. And I think this is also important for the project manager mainly, because every time you have to report on how the project is going, you have to take a look to the whole situation. And using a tool like the one that's being developed in iProd, we will be able to make the life easier to the project manager. So, further to this, we can also provide an integrated view of the project using this tool, because you have all the information all together. We can also adapt faster to changes thanks to the correlation matrix. It means that if, for instance, during the development of the project, you have a change in any of the requirements or a change in any of the, let's say, the property materials, for instance, you can introduce this information into the software so that you can immediately know which parts are being affected by this modification, which are the tests, if there is any that needs to be updated or repeated, and what is the, how this is affecting the planning in your product development. I think in the future we can have the creation of virtual models automatically by the software based on the design rules that we are teaching the software when we introduce the information. So this is something that is a great potential for the years to come. We can also generate and execute integrated design and test through workflow optimization. I think there is no need to further explain. We have seen a lot of how this can work and what are the advantages of optimizing workflow in the previous presentations. But in the end, it will take you to shorten the development time. About what are the benefits in the reduction on the product testing cost. We can save cost in testing during the test execution or during the test replanning in case it is necessary. How can this be done? we have, with the iProd tool, better access and relation of the virtual and physical test and their historic progress. And we have this thanks to the correlation matrix. So it means that if I am developing parts which are similar to parts I have developed in the past, I can learn from my previous experience. So I can find that maybe if I find that if I meet the requirements of 2 of the tests I'm doing, a 3rd test I can skip, because I know that every time I'm okay in 2 of the previous tests, this 3rd test is also okay. So in this sense, I could save test. Safe test is also saying safe prototypes, which are very expensive. We can better identify the physical test that can be replaced by virtual test. Again, thanks to the correlation matrix. I can clearly see, thanks to the information available from my previous experience, that if my models are reliable enough and I am having a very good predictability in my simulation, this can lead me to avoiding further testing. In this way, I could replace physical test by virtual testing. And we can also have a reduction of the number of prototypes and tests, well, as I explained before. So checking if a test is relevant is also another advantage, thanks to the historic results and the relation to the functionality. So in what concerns to the reduction in the warranty claims and field repair costs and manufacturing efficiencies, this can be done in all the phases of the product development process. And this can be done through the increase of the product performance and the product maturity by optimizing the design cycles. We can also improve the quality of the exchange information with semantically consistency rules. And this is relying on the ontology principles implemented in the software tool. I will not go in detail in these ontologies because, frankly speaking, it's a topic which is complicated for me. There are very good experts here that will explain further on this in the next presentations. We can also check for the quality consistency during the code development process. And in the end, what is the meaning of all this? We think that the iProd software is addressing the real industry need. So what I have shown is based on the use case story, the one from the automotive company developing a suspension arm, a simple case, how providing a specific data and knowledge to the project, we can develop a tool which is able to address to the real industrial needs in the improvement of the product development process. So what we expect in the end of the project from this tool is that it will support the companies to launch competitive products with good performance at a reasonable price and on time, which is very important. So in the end, I think this is what every company wants. So I would like to thank to the European Commission for partly funding this research project, which is being done within the 7th framework program. And well, I thank you for your attention.